Hello everyone, welcome to the channel and I hope everyone is doing good. So in today's video, we are going to discuss about re-ranking, one of the optimization of RAG pipeline. So before getting into detail like what is re-ranking, why we need re-ranking, how it works, I just want to show you the overall picture like where the re-ranking lies in the RAG pipeline. So you can see in the screen on the screen. So this is a user query. This is the document. Consider it as a vector database where the document is there in the embedding ways, and from there we get the chunks. Like we are doing the retrieval from the vector database, and these are the chunks. These are the top n or top 10, 20 or top 10 chunks. Now after this, we put here re-ranking. We use re-ranking model and we apply re-ranking here on the top of this retrieve documents, and then this document are ranked as per the relevance. Like the document which is very much near to the answer of the query, that will be ranked as a 1 or the highest rank. So this way we put ranking in this picture. Now there is one question like why don't we use re-ranking in the retrieval itself? It will be easy, like all the result will be very much of relevance. But re-ranking consumes CPU. It brings the latency in your response because now this document has to go to LLM. Now when you use re-ranking, then generating this relevant document out of this top n or top 20 document will take some time because re-ranking will take some time to generate this. So in a RAG system where your accuracy doesn't matter much, it matters to some extent, but the response time matters most, then we don't use re-ranking. But in the RAG system where the accuracy matter the most, you want that your document should be very much of accuracy. In that case, we use re-ranking. I hope you would understand that where we use re-ranking. Now, from this part of the video, we'll look into why we need re-ranking and all that process of introduction of re-ranking and how re-ranking goes into the process. So this will help you to understanding the further part of the videos. So guys, if you have not subscribed to the channel, please do subscribe to the channel and do spread this video and this channel to your friends or colleagues to whom this video and this channel is more relevant. So let's start the video now. So now we have understood that where re-ranking gets into the RAG pipeline. Now, why re-ranking is important? So before that, we have to understand that why we need re-ranking. What is the problem statement? So now the problem is in the retrieve document. So there are two big phases of the RAG. One is before retrieval, how to retrieve the correct document, and second is how to identify the relevant documents out of the retrieve document. So these two parts we have to generally deal with when we look into the optimization of the RAG pipeline. So re-ranking focuses on the document after we retrieve the document from the vector database. So what happened, like every time when this document is retrieved from the vector database is not accurate because in vector database there is a vector information, multidimensional vector, and it carries the semantic meaning. So near to the vector, then there is a vector number. So near to that vector dimension, vector number in that dimension is fetched. So there are high possibility that your retrieval document may not be very much relevant. So it may not be relevant information. There will be multiple noise in the context. The semantics maybe the output may be semantically similar, but your answer or the document will be incorrect. There will be duplicate chunks. So there will be multiple issues with the retrieve document. So to cater all that issues, to solve the problem of all that these issues, we have to use re-ranking. So re-ranking helps you to re-rank, give the new rank to the output, to the number of document which you have fetched from the retrieval, based on the accuracy, based on the relevance of the document. Now, before going into how re-ranking works, what are the different models of re-ranking, what are the different types of re-ranking, that being more of an interview kind of questions, I want to first discuss about one of the example. We'll take one simple example and then we'll understand how re-ranking improves your efficiency of your RAG system or overall RAG answering system. So for example, I have a RAG system for an insurance company. Okay. Now in the vector database, which contains the external knowledge source. So we have a knowledge base contains, means the vector database contains claim policies, travel insurance information, fraud documents, legal agreement, reimbursement guides. Okay, these are the problems. These are the information which is are available in your RAG system, vector database. Now, a user fired the query: can international medical expense be reimbursed? So this is the query, and this query answer need to be searched from this information which is stored in a vector database. Now, if your RAG system gives this kind of retrieval, this kind of output after the retrieval, like the first document is domestic reimbursement, rank 1, travel claim frequently asked question, rank 2, and international medical policy, rank 3. Okay. Now the problem is the correct answer is the third one, but the third one is given the least preference. So here the re-ranking will help you to give or increase the rank of the international medical policy document, and that will be more relevant to the user query. So when we apply re-ranking, so your international medical policy rank becomes 1 and the other becomes the other rank. So your most relevant documents or most relevant answers becomes the first answer or first document in the retrieval list. So this will, in this case of scenario, your re-ranking helps a lot in giving the most accurate answer. So we've seen this example. Now we'll see like how re-ranking works. So now we'll see how re-ranking works internally. So there are few steps which we follow for the re-ranking. The first one is initial retrieval. Like when you fired a question to your RAG system. So from vector database, you get the initial retrieval documents. Then vector database retrieves top k result. We ask to give particular number of result like top 20, top 10. So it doesn't gives the full information. From that top k information, we do pairwise scoring. Pairwise scoring means we start doing the re-ranking. So like as we have discussed, after the retrieval from the vector database, we try to do the re-ranking. So re-ranking evaluates query and chunk 1. So what happens actually, for example, the 3 chunks you have got it from the vector DB retrieval. So it will create one section where the query is there, like query is how re-ranking works internally, and then chunk 1, then same query chunk 2, and then it will compare this output is the chunk 1 for the query remains the same, chunk is the output, one output of the retrieval from the vector database. It will compare the output of each chunk, like output as each chunk, and then give the relevance score. It just brings or calculate the relevance score that is done by the re-ranking model. So chunk ABC, like we have 3 chunks, we have given the name ABC, and the score is given. Now the chunks which has the highest score will be more relevant, and then once the score is there, then sorting is done. So document is sorted by the score. So once the sorting is done, then the more relevance document will be at the top. So this way the re-ranking works. Now we'll see that with the help of Python code, like how we implement re-ranking. Like I'm not using any of the workflow engine or any of the framework like LangChain or LangGraph. That will overall improve that in that you have to write very less code. But in normal Python, how it will work? First, you have to install the libraries, sentence transformer. Then in the step 2, we have to load the re-rank model. So there are multiple re-rank model. I'll just give the list of the re-rank model. So one of the model is cross encoder, and these are the types also of re-ranking. So we'll just load the re-rank model, and then we'll give some sample queries and document. These document are actually retrieved from the what do you call, from the vector database. So I'm not using any RAG system. I'm just going on to show you how re-ranking works with the help of code. So if you're firing this query, for example, how to migrate EMR jobs to EMR serverless. So this will be fired into vector database, and your output will be this document. So as we are not using any of the RAG pipelines, so I have just given the document as EMR billing optimizer technique, guide for EMR persistent cluster. So these are few of the output of your RAG system. Now in the step 4, what we are going to do, we are going to create the pair. Like this is one of the answer, one of the document, and the query. So query and the document and the chunk. Query, then another chunk. So we are going to prepare query document for doc in documents. Okay. Step 5, we have to create the relevance of each pair. So what we are going to predict the relevance of each pair, and that score is given. So 0.15, these scores are given as an output when, like, these are the output of it when we create the pair of query and the chunk, and then create the score out of it. Okay, now once you get this output, what we have to do, we have to rank it. Okay, so in step 6, you can call it, you can rank this or you can sort this particular output, and that sorting will gives you the more relevant output at the top. For example, guide for EMR persistent cluster migration, like this is more relevant to your queries, and so the rank has been given more. And while doing sorting, this becomes the first document. So what are the process? First install the libraries, then load the re-rank model, then gets the output from the vector database, create the query document pair, and then add or just take out the relevance number of that pair, and then sort that pair, relevance number of the pair, to get your final more relevant output, and then this is passed to the LLM to give you the proper response. So this is how re-ranking works. But still, if you're going to use LangGraph in that, or LangChain, so then you don't have to write these many codes. That can be done in a single 2 or 3 lines. So there are generally 3 disadvantages of ranking or challenges in the ranking. First is like what we have discussed in the first part of the video, that it increases the latency, because you are including one system before getting the document into LLM. So that increases the latency, higher compute cost. Obviously, that pair query and the chunk pair, the scoring has to be calculated, and then sorting, that will be having the compute cost and scaling complexity. When your output is big, when your query is complex, in that case, this latency will increase at so large number that it will be very difficult to scale this. Now, in this video, I've just given the very overview of re-ranking. I have not covered what are the different types of re-ranking, what are different use cases of re-ranking as per all the types, what are different models, and what are the advantage of few models, in what use case you have to use. So we have not discussed that. That will come in another video where I'll be discussing about the interview question specific to re-ranking. But this video was just for an overview for the beginners. In the next video, I'll come up with the interview question of re-ranking, where I will discuss almost everything of re-ranking from the basis of from the perspective of the interview. Okay, we'll meet in the next video. Do subscribe to our channel. Till then, be happy and happy learning.